sequence? Okay. Does anybody know this word, sequence?
Yeah.
You know it? Amanda, Grace, and Sophie. Do any of you know this word, sequence? You know it, Sophie? Was that you, Sophie, that said yes? No? Must have been Grace. Grace, do you know this word?
No.
Then it must have been Amanda. Amanda, do you know this word? No. So just imagine one of you said yes.
No, someone said it.
Wasn't one of you then, no? Who knows this word, sequence? Move down, I can't see them. Move down. Move down, I can't see everybody and you sit in the corner. Go, move. Sequence, who knows it? You know this one word, KJ? Yeah? Correct?
It's supposed to mean command.
Yeah.
Command.
Continue, yeah. So sequence, we think of it like as a list. And it has an order. And it has a rule. So for example, 3, 5, 7, 9, 11, etc. This is a sequence. This is an example of a sequence. That's a sequence. Okay? So notice here I said there's a rule. So in this example, what is the rule to make the next number? Plus 2. This is like the rule. Who can tell me what's next here?
Multiply.
Is it multiply? I'll give you a minute. I'll give you 1 minute. Have a think, and then in a minute I'll see what your answer is. Don't tell me yet. No, don't tell me yet. I'll wait till everybody had a chance. Just write it down if you know it. Right, who thinks they know, firstly? Who thinks they know? Tacken, you think you know? Do you? What's that, DJ? Do you know? Anyone else? You think it's 26? Tacken, what do you think? Yeah, it is 26, because what's happening here is this is plus 2, plus 3, plus 4, plus 5, plus 6, so the next one is plus 7. Okay, so this is what we mean by sequence. Right, so we need to have some symbols here. So if I say X is a sequence, it's like X1, we call this the first term, and then you get the idea. X2, we call this like the second term, and then X3, etc., etc. So for example, if X is the sequence, what was my first example? Well, we'll do something like 1, 3, 5, 7, dot, 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 dot. This one here is X1, this one here is X2, this one here is X3, and so on. Okay. Right, so we can write down formulas to make the sequence. Can I scroll down? In a minute. Huh? That's another lesson, not today. Okay? Not okay, Amanda? Everything is bad? Everything is okay?
Okay.
Everything is bad, okay. Right, can I go down? Yep. Yeah. So, for example, un equals 2 plus 3n. This is a formula for a sequence. If I wanted the first term, this is an example, what I would do is replace n with 1. So what's my first term here? 5. If I want the second term, 2 plus 3 times 2, what's that? What's it? 8. And one more, 11. So we can use a formula to make a sequence. Now let me give you a sequence and maybe someone can tell me the formula. So for example, if I have like this 2, 4, 6, 8, etc. and we call this the sequence U. What do you think the formula might be for this sequence?
2 plus...
No?
I have
2n. Just 2n. Yeah, and then let's do one more. What about this sequence? We'll call it V. 1, 4, 9, 16, 25, 36, 49, etc. Yeah, Vn equals n squared. Just a different letter. There's no difference. You can use whatever letter you want.
You can use A.
Could use A if you want. Okay, you got that? Are you writing this down for hand, yeah? Have you all got this? So these formulas, these are called like direct formulas. These are all direct, explicit, straightforward. Now we're going to look at another type of formula. We call it recursive. Yeah, recursive. Oh, I should say actually, this chapter is very important for your assignment, your project. Remember, I said there's a 10% maths project in this semester? You remember that? You do remember. Now don't pretend. At the start of the year, I said there's a 10% maths project in this semester. I'm saying it's about this chapter. Yeah. So this is an important chapter for your project. Yes? Yes?
And when we
I'll give you the information later. I'm just saying about this.
sequence.
Please? No. Sequence, yes. You'll see it, don't worry. Now, recursive. So for example, imagine I told you something like this, that the next term is 2 plus the last term. Start at 5. Okay, so let's see what happens if I try to do this. I start at 5. Are we looking? I start at 5. What's the next term?
7.
7. And how did you get that, Karar?
5 plus 2.
5 plus 2. Yeah. What's the next term?
9.
What's the next term? 11. This is called a recursive sequence because you have to use the last number to make the next number. In the formula, you actually write this one as un plus 1, this is like the next term, is equal to 2 plus un, and this is like the last term, the previous term. This is called a recursive sequence. Okay, let me just get something. Alright, do you have that? Yeah? Can I scroll down? Not yet. Yes? Okay. So let me give you another example. Let's say the next term is the last term squared, and I tell you to start at 2. Okay, so I start at 2. The next term, u2, equals u1 squared. So what would that be? 4. u3 equals u2 squared. 16. u4 equals u3 squared. 256, isn't it? Etc. Do you see what's happening? In this one here, for example, if I take this one as an example, if you want to know what u3 is, that's equal to u2 squared. And that's coming from this formula. This is called recursive. In English, recursive means it goes back in. You know, it's like a loop. So the next one, what would u5 be? It would be u4 squared, 256 squared. You see what's happening? Yep. So what I want to do is just to make sure you understand, because it's for your project and students get confused on this, I'm going to give you 2 sequences, and I want you to give me the first 4 numbers in each. Okay, so here's the first one I want you to do. un equals n factorial. Give me the first 4 terms. And then after that one, do this one here. un plus 1 equals 1 plus 1 over un. And again, give me the first 4 terms. Now, hey, don't talk when I'm talking. When you have a formula that's recursive, I must tell you where to start. So I'll tell you to start with u1 equals 1. Okay? So I'll give you a minute, a couple of minutes. Give me these 2 questions, 1, 2.
First one starts with what?
I don't need to tell you, because for these ones here, you always start with n equals 1, 2, 3, 4. Yep. Yeah? Anybody else? So this first one here, U. What's the first number? 1. Next? 2. Next? 6. For this one. 3 factorial. Next? 24, etc. This is 1 factorial, 2 factorial, 3 factorial, 4. Is that okay? Yeah? Now the next one's a little bit trickier. Let's have a look at the second one now. That was the first one. Now, sorry, that was the first one. Let's have a look at the second one. So U1 equals 1, because I tell you. U2 equals 1 plus 1 over 1, which equals 2. U3 equals 1 plus 1 over 2, which is 3 over 2, yeah. U4 equals 1 plus 1 over 3 over 2, which is 5 over 3. 5 over 3. Which is 1.5, which is 1.667. Yeah? Okay. Now, what I want you to do, can I scroll down a little bit? Just a little bit to here. What is the 10th term in UN equals 1 over n? So, that's actually kind of easy to do. Who can tell me the answer here? What is the 10th term in this sequence? Just 1 over 10. It will be 0.1. What's the first term?
1.
Second term?
1.
Well, as a decimal?
1.
As a decimal? 0.5. Fifth term? 0.2 for the sixth term. For the sixth term? No, 0.166, yeah? And so on. Anyway, what about if I asked you here for the 100th term? It'd be 1 over 100. Now, what about if I go back to this one? What if I ask you for U100? Is it easy to do? No, because you have to do each step until you get to 100. Yeah? So, let's get Excel to do that. Because in your project, I'll expect you to use Excel. Now, don't worry, we'll use Excel in ICT class on Friday. We'll do a tutorial on it. But let's have a look at an example. So, U, what did I tell you to start with? It was 1, wasn't it? And then I say the next term is 1 plus 1 over the last term. Okay, so what was my next answer? It was 2. And what was next? What was after that? You have it there. It was 1.5, wasn't it?
Yeah.
Yeah, and what was after 1.5?
1.6.
Yeah, 1.66, yeah. Now let's go to 100. Now look what's happening here. It goes 1, 2, 1.5, 1.6, 1.6. Make this a bit bigger for you. But do you notice what's happening here? After a while, it stops changing. Do you see that?
Yeah.
It starts to stay the same. When this happens, we call this sequence, we use the word convergent. When this happens, we say the sequence is convergent. This means what you see, that it's moving to one answer. It wants to be at one answer. This we call convergent. That is a very important word for the exam, for your project. Please don't forget it. Convergent. Okay. Let's have a look at another sequence. Let me call this sequence V. So let me make V like this. Let's say Vn equals, let's say it is Vn plus 1 is 3 over 2 multiplied Vn. And I tell you to, no, let's make it easier. Let's make our lives easy. Vn plus 1 equals 2 Vn. And I tell you to start at 1. Okay. So what's the first term?
No, 1.
The second term? 2. The third term? 4, and so on. So let's have a look here. 2. 4, what's next? No. 8. 16. 32. Okay, let's get the 100th term. And you can't see what's happening here, but it's getting really, really big. See that? And in Excel, you see this E thing here? This means 10 power 23. Yes, indeed. So this is 10 power 29. So is this sequence convergent? No. It's going to infinity. It's getting bigger and bigger. So we call this, does anyone know the opposite of convergent? Divergent, yeah. Okay, you got that word? Divergent? Okay. Right, and we'll do one more word, which is, so here is W. Okay, so we'll make W over here. So let's say W equals minus Wn, and I tell you to start with, let's say, start at 5. So what does W1 equal? No, that's W2. 5. And W2? Minus 5. And W3? It'd be 5, yeah, because it would be minus 5, which is 5. So what's happening here? Let's have a look. So I ask you to start at 5, and the next one's minus 5, and then 5, minus 5, 5, minus 5. So, what word describes this? Periodic.
If something stays as same
I'm not sure how to spell periodic anymore. Periodic. Period. Problem solved. Let me just double check. Period. That's my head. Periodic.
The question would be if some sequence has 2 values.
It could be 2, yeah, it could be like cycling between 2 values, like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's periodic.
Pair of
Yeah. So, periodic means it repeats. So you could have 1, 2, 3, 1, 2, 3, 1, 2, 3, like this. Okay, so have you got those words? Convergent, divergent, periodic. Yeah? Okay, so what I want you to do for me right now, I'm going to give you a sequence, and I want you to calculate the first 4 terms, and then I want you to tell me if you think it is convergent, divergent, or periodic. And 4 should be enough. After 4 terms you should be able to tell. So let's say here, I say xn plus 1 equals 5 over 4 with a minus xn. And I tell you to start at 5. So I want you to give me the first 4 terms and then decide if you think it's convergent, divergent or periodic. How are we doing? We got the answer? I can't see what you're doing. Let me see. Yeah. Yeah, okay. So what do you think? Is it convergent, divergent, or periodic?
Divergent.
What do you think?
Divergent.
No, I don't think so. I think it's divergent because it keeps getting bigger. It does, I know, yeah. In other words, it's not trying to reach a single number. It's just going up and down like this. If you draw the graph, it's going like this. Big, moving up and down like this. Yeah? I think this is divergent. Or divergent? Yeah, I should be clear. I just mean the number becomes bigger. I don't care if it's plus or minus. Yeah. So, what do you think now? Convergent or divergent? I think it's divergent. No, just because I say it's divergent doesn't mean it's divergent, although it is divergent. Yeah. Now, for these recursive sequences, you can actually use your calculator to make the sequence very quickly. So let me tell you how. So I'll wait till you're ready, and then we follow and see, because this is not the same, the instructions will be different for you. Alright.
So do that.
Huh? What's that?
So this time.
It might be okay. Here, let me. I haven't shown you my little code I wrote. Watch this. Wait. Give it a second. There we go. There we go. Calculator time. Do you like this little feature I made? Right. So, listen carefully to my instructions. I'll use this one as an example, okay? Yeah, we're doing okay? You're explaining something to her, yeah? Yeah. It's okay?
There is a threshold in these,
In what? Threshold? In what?
you know, threshold.
Yeah. For what though? What's the context?
For those?
Minimum?
No,
What do you mean threshold? Oh, or the calculations, we usually use 4 significant figures.
in all else, it's not something if you got, in all else, there's a threshold. If they say the paper is hard, you got good marks.
No, not this time. Sorry. Okay, you got your calculator ready? So, what you do first, Grace, are you ready? You're ready, yes? Got your calculator? So, what you do first is you type in the first number. What's the first term here? 5. So just press 5 and then press equals. Have you done that?
Yeah.
And it says 5 on the screen, got that? Yeah, okay. Then press AC. And it's gone, yes? You done that? Yes. Now what you do is you type in the formula, but you see, because you have a different calculator, I'll give it to you later. So what you do is you type in the formula, but instead of xn, you press ans, A-N-S. So what I would type minus fraction 5/4 and then ans. So look, this is what you want to type on your screen. Oh, you see? There, up there. Have you done that? I think you can. We'll probably just press on, maybe. But where's Anson there? There it is, there. Right, hang on. We're going too fast. How have we done that? Great, let's see your calculator. Right, start again. Ready? Right. Just do what I ask you to do, and that's all. Right? Calculator in your hand, yes? Not in your mouth. In your hand, yes? And 5 and equals. Have you done that? And then AC. AC?
You just touch the delay.
Yeah.
It's okay.
That's what I want to do. Like, hang on, KJ, Karar, where's your calculator, Karar? Come on. You're the only one about it. No. Nobody talk. Just listen and do exactly what I said. You ready? Now, you just have to wait until the second round. No, leave it alone. He made his choices. Right. So, calculator is on. 5 and equals. Done? Yes. AC. Now the screen should be blank. It's gone, yes?
It is not important.
No, it is important. It is. It is. Now, is screen blank? Yes?
I know this one.
Don't talk. Now, what you want to type in is minus 5/4 and then ANS, the answer button here. So on your screen it says minus 5/4 ANS. Like this. No, 5/4. I've got 4/5. Yes. Can I see yours, Sophie? Yes, and I can see yours, please, Amanda?
I know this.
Why did you do it? Have you, do what I asked you to do and type it in. Good.
I know M.
No, this is fine. Just leave it like this for a moment. Okay. Good. Now, when you press equals, what you will get is the second term. See? Where's your second term? Where's your answer? Here it is here, 25/4. Is that what you have? Yeah, 25/4. And then when you press it again, you get the next term. And you press it again, you get the next term. So you can keep making it. Okay, let's do the one I did earlier with the 1 plus 1 over. You remember that one? Do you? Here, I'll show you. This one here. Let's do this one together. So what do I type first for this one?
1.
1 equals AC. Got it?
Equal.
This is equal, yeah, and then equals, yeah, and then AC. Okay. And then type in 1 plus 1 over ANS. See? 1 plus 1 over ANS. Let's see. Okay, now press equals. What did you all get? Press equals? 2. And again? Equals? You keep pressing it?
2 over 3.
Now keep pressing equals.
1 over 3.
Keep pressing. Keep pressing.
8 over 1.
Keep going.
13 over 8.
Are you starting to get this number?
Yeah,
Oh,
it's 10.
yeah.
Nice. It's 10.
Magic.
In primary school, oh no, in the middle school, they know this.
Oh good. So then why are you giving me a hard time?
Because I don't use calculator.
I know this is a good thing. But for the exam and for your project, you can use the calculator.
Time.
You can't.
Let me be very clear.
Yes.
For the project and the exam and the class and your life,
Yes.
you can use the calculator. Yeah, calculator, good. All right. Now, let me give you some questions out of this to do. Are you speaking Chinese?
Yes. I said I never used calculator before.
Well, now you do.
Yes.
And don't you feel so happy?
I'm very
Are
happy.
you very happy, yes? All right, number 1, I want you to do ABC.
Wait.
Number 1, ABC. Number 2, ABC. ABC. Number 2, ABC. Number 3, ABC. Now, in number 4,
Nothing.
no, this is very important. Number 3, ABC. ABC. Now, in number 4, we see, actually, let me see, D, no,
That's good actually.
yeah, C.
Yeah. Oh my God.
And please note, in number 5, it's connected to number 4. In number 5, I want you to say if your answers in number 4 are convergent, divergent, or periodic. So,
No, seriously. I'm not the same page as you. You tricked me.
I tricked you, didn't I?
Yeah. I don't believe you.
You shouldn't believe me.
No, I don't want to believe
Yeah, ABC, DIFC.
Exactly.
Yeah. Hey, I'm not finished. Get your stuff out. Get your stuff out, because there's another example I want to show before you go on the board. Yeah, and you need to write it down because it's related to your project. Your notepad out.
I remember
Is it difficult to... Hang on, let me just pause the video for a second here. Here you go. Take out your notebook. Look, don't make my life difficult. I won't make your life too difficult.
What's 6?
6, yeah, you need to do. It's just a graph. Now, just before you go, KJ, before you go, please write this example down.
Are you free on next class?
KJ, hang on, I have to decide if it's important. It can probably wait. Okay. Just write this one example down. So just to show you, sometimes you can have a sequence that depends on the last two terms. So for example, if I tell you to start at f1 equals 1 and f2 equals 1, you see what I'm saying here? That I'm saying the next term is the last term and the term before that. It's the last two terms. So for example here, what's f1? 1. What's f2? 1. What's f3? 2. What's f4? 3. f5? 5. f6? 8. f7? 13. f8? 21. You see what's happening? That you add the last two terms to make the next term. Now this is actually important for your project, KJ, because in your project you will have one of these sequences to deal with, where it's recursive and it depends on the last two terms.
What's the name of this?
It's still just called recursive, but it has two terms instead of one term. Okay? So this is important for what, KJ? For your safety, yes. Yeah? This is important for your project. And we'll talk more about the project maybe next week. Okay? Because if I can give you the project before the break, then you have some time to work on it.
Okay.
See you.